here, so it will be mouth previous image ta dekhuji. So now it will be here negative and polarity changes. Here it is positive. So here it will be negative, right? And here it will be positive. ठीक ଅଛି ठीक ଅଛି ନା ନାଇଁ?
Yes, ma'am.
So now as it
Yes,
is
ma'am.
positive here, so positive is connected to the P terminal in the D2 and negative is connected to the P terminal of D1. So it will be reverse bias and it will be forward bias, right? So D2 is in forward bias
Yes, ma'am.
now. Change hai gala. So coming to the next one. See, now here it is reverse bias, open circuit. Here it is forward bias, D2 is forward bias. So it is short circuit. Now current flow will be like this, right? So again it will be Vi positive to negative minus V naught equals to 0. So you can say Vi equals to V naught. Correct or not?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So
Yes,
again you
ma'am.
are getting whatever input you have given, same thing you are getting as your output. So you are getting full wave rectification, right? So coming to the coming to the comparison, you can say number of diodes. If I compare the number of diodes, okay, in half wave rectifier, only one diode is used, right? In the full wave rectifier, it is 2 to 4. Yes or no? Back
Yes, ma'am.
VDC, IDC, means average value, RMS value, all will remain same for center tap and full wave rectifier. Yes or no? Because output is same.
Yes, ma'am.
So same thing we will see number of diodes. It will be in half wave rectifier it will be one, in full wave rectifier it will be two, or for two where center tap. In center tap it will be two, right? And the bridge it will be four. Yes or no?
4.
Now maximum efficiency, if you see in half wave you have calculated 40.53, in full wave 81.06, nearly equals to 81. Okay. Similarly, peak inverse voltage if you will consider, for half wave you will get Vm, for full wave you will get 2 Vm. Vm or 2 Vm. 2 Vm you can find out in your center tap. Okay.
Yes,
Then
ma'am.
average voltage with no load, that is Vm by pi and 2 Vm by pi. Same RMS you will get Vm by 2 or Vm by root 2. Ripple factor will be 1.21 for half wave rectifier, 0.48 for full wave rectifier. Jette ripple factor कम होगा, it means
Better.
better,
No
right?
wastage
Ma'am,
of
the
current.
No
practical
extra
Right,
energy.
right. Now,
Efficiency बढ़
okay. Now you can say form factor is 1.57 and it is 1.11 here. So output frequency is F in half wave rectifier and 2F in full wave rectifier. Okay. So I am giving you an example. Is it visible?
No, ma'am.
No,
Not
ma'am.
visible.
no, ma'am.
No, you are not presenting.
ଓ ସେତେବେଳୁ comparison ଟା ବି ଦେଖି ପାରୁନଥିଲ ତମାନେ?
Yes, ma'am.
Comparison was
ଏ
visible.
No, ma'am, ସେଇଟା ଦେଖିଛି.
ଏଇଟା ଦେଖା ଯାଉଥିଲା, PPT ସେୟାର କଲେ ହଉନି, ଏବେ ଦେଖାଗଲା?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So in example, suppose this is the example I have taken, you can consider this was the book example time ମୁଁ କରିଛି, ଠିକ ଅଛି? ତ ମାନେ ନିଜେ ବି verify କରିପାରିବ. Suppose this is your circuit, okay? In this type of circuit, only two diodes are been given. Here, 2 kilo ohm resistance are given. So you can find out your value, okay? Output DC level. This is the input given to you, okay? So now input is given. So तमे कौन करिबो? First positive half consider करिबो, then negative half करिबो. So for the positive half, this will be the positive terminal, negative terminal. Positive terminal is connecting here. It means this is reverse biasing, and this will be in forward biasing mode. So forward biasing, short circuit, reverse biasing, open circuit. Now you can take the conduction path. Yes or no? This will be the conduction path through this short circuit path. Yes or no? You can consider this one,
Yes, ma'am.
and you can find out your values, because this is the conduction path. I can represent this in this way. 2 kilo ohm, 2 kilo ohm, 2 kilo ohm is here. Now this 2 kilo 2, this one and this one is in series. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So by using these two in series and this is in parallel, you can find out your value. हाँ कोई दोजन संगे संगे ना मैं
Yes,
किसी भी
ma'am.
कहले हाँ ना कौन अरे निजर टिके यूज कर हाँ कौन कहूच एटा कनेक्शन सजेस्ट कल कौन अच्छी केमती अच्छी कनेक्शन भल से देख केमिति अच्छी कंडक्शन पाथ तो जानी गलो एमिति आसुची राइट तबे को पटे जीव कौन करियो एठी तो गोटे नोड हे गला ए नोड रो in this way, again in this way current, this one is the node. Yes or no?
Yes, ma'am. 2 are in
So,
series
Ma'am,
and 1 in parallel.
2
suppose
kilometers
wait,
series
wait,
है.
wait, wait. Let me as these are same resistance, I'm giving name R1. This is R2, and this is R3. Now tell me. Now tell me.
Ma'am, R2, R3 series रहते हैं
R2
and
in
the
series and
parallel
R1
to R1.
R1 and R2 are in series, ma'am.
R1 with R1.
R1 and R2 are in
R1
series,
and
ma'am.
R2.
Correct.
R1
This is the node A. No, from node A, the current is flowing in R1. Then it will come and flow in this path, right? So same current will flow through R1 and R2. So you can say R1 and R2 are in series. Now from this node A, this will be I1 and this will be I2. I2 will flow through R3. Different current will flow through R3. So you will say R3 is in parallel to R1 and R2. R1, R2 in series and R3 is in parallel connection. So this will be your R3. This will be your R1 and this is your R2. ଏବେ ବୁଝି ପାରିଲ
Yes, ma'am.
ବୁଝି ପାରିଲ ନା କାର ଡାଉଟ ରହିଲା
Yes,
ଯୋଉ
ma'am.
ମାନେ କହୁଥିଲ R2 R3 ସିରିଜ ରେ ଅଛି फर्स्ट देखिले ऑब्वियसली इफ यू डिडंट गो थ्रू द एनालिसिस एमती हठात देखिले तुमको लागिबो कि हां R2 R3 इज इन सीरीज आर यू गेटिंग माय पॉइंट और नॉट
Yes, ma'am.
Yes, ma'am.
right
Yes, ma'am.
so in this path suppose this is I1 from this node A okay current will be distributed I1 and this will be I2 right and same I1 will flow through this direction as well okay so R1 R2 in series R3 in parallel now you can solve right एबे solve कर परिबो
Yes, ma'am.
and तमे V0 टा कोडी नउचो R1 across रे नउचो V0 right you will take V0 across R1 right so VI right here it is VI right so now this is the node A and R1 R2 in series R3 in parallel so VI then here it is the V0 minus V0 then minus VR2 yes or no by using this KVL you can find out your V0 value है ना नहीं
Yes, ma'am.
because
Yes,
R1
ma'am.
and R2 are in same R1 R2 R3 all are having same values है ना नहीं
Yes, ma'am.
so V0 you can say 1 by 2 VI
Yes, ma'am.
निजे KVL apply करो एमती KVL टा apply कर दिया जदि न जानि परचो because both are having same R value that is 2 kilo ohm
Yes, ma'am. ବୁଝିହେଲା।
ବୁଝିପାରିଲ VI
Yes,
minus
ma'am.
I into R minus I into R1 and R2 is equals to 0, and R1 R2 are same, so you can say VI minus I into R, because R1 R2 are same, right? So you can take common, right? So now there, from there you can find out that will be half of VI. Okay, now you can take your V naught. V naught you have derived. Now VDC and VDC also you can find out. तमर formula पके के भी तमे VDC find out कर परिबो, ठीक अछि? Then you can draw this circuit. तो तमे negative half पाई भी already तमे find out कर परिबो. You can check your negative half, what will come, then you can find out the values. Okay. Half of VI, that will be 5 volt, right? Half of VI, because VI is 10 volt. So half of VI you will get 5 volt, okay?
मैम मैम VDC रे VM by pi पकड़े ना 2 VM by pi
तमे को कौन पकेबो?
मैं R3 टाको एक्सक्लूड करा हला
Sorry?
R3
हाँ तमे 8 नहीं के भी कैलकुलेट करो, एक कथा. Positive half, negative half देखो, डेटा चक्कर रेक्टिफिकेशन हो ची कि नहीं, then you can find out the value. Negative half रे कौन होबो? Negative half रे कौन है जीवो? आ गोटे डायोड, this will be short circuit and this will be open circuit. Yes or no? तमे केमती
Yes,
जानिबो,
ma'am.
तमे फुल वेव होची कि हाफ वेव होची आगे चेक करिवो. एबे नेगेटिव हाफ रे कोन हबो, एटा
Yes,
शॉर्ट
ma'am.
सर्किट हे गला, एटा ओपन सर्किट हे गला, तो कंडक्शन पाथ चेंज होला, केमती हबो कंडक्शन? हियर सॉरी, एटी भी पोलैरिटी चेंज हे जिवो. नेगेटिव हाफ मु करूची, नेगेटिव हियर, पॉजिटिव हियर, सो केमती आसीबो? कंडक्शन पाथ केमती हबो?
रिवर्स
रिवर्स रे केमती जिवो? एटी के आसीला, एटा गोटे नोड हे गला.
नोड पॉइंट
Now एपटे भी गोटे करंट फ्लो कला, एपटे भी गोटे करंट फ्लो कला. Suppose this is I2, this is I1. Now I1 will flow. केमती फ्लो करिवो?
हम I2 R1 देखि जीव I1
I2 time में जिवो, then across this, then coming to here. But
Yes, ma'am.
8 भी आ गोटे नोड होला, एटा 80 जाई के मर्ज होची. हां, तो सही हिसाब रे अगेन कैलकुलेट करो. From this node it will be entering, again it will be entering, right? You can find this path.
Yes, ma'am.
सर्किट एनालिसिस करो तो तुम्हारा फुल वेव रेक्टिफिकेशन होची कि नहीं तमे चेक करो. ठीक है, जदि फुल वेव होची देन फुल वेव पकेबो, जदि हाफ वेव होची देन हाफ वेव पकेबो. आर यू गेटिंग माय पॉइंट और नॉट?
Yes, ma'am. Understood. Yes, ma'am.
Yes, ma'am.
So have you heard about the term transistor or not?
Yes, ma'am.
What is it? What is it?
Ma'am, it is basically a 3-terminal device.
Three terminal device, then
Two type আছে
There are
PNP
three
and PNP.
three terminal device, then what?
पुणे देखो two type ଅଛି PNP transistor and NPN transistor.
PNP and PN transistor, अच्छा. How? ଆଉ କ'ଣ ଜାଣିଛ?
ମ୍ୟାମ୍ ସେଇଟା ଗୋଟେ ସେମିକଣ୍ଡକ୍ଟର ଡିଭାଇସ୍ ଯୋଉଟା କି ପାୱାର ସୁଇଚ୍ କରିବାରେ ୟୁଜ୍।
ପାୱାର ସୁଇଚ୍ କରିବାରେ ୟୁଜ୍ ହୁଏ।
ମ୍ୟାମ୍
It has
ଇଲେକ୍ଟ୍ରିକ
collector,
ସିଗ୍ନାଲ୍ସ
base
ଆଉ
and
ପାୱାର।
emitter.
ମ୍ୟାମ୍ ଇଲେକ୍ଟ୍ରିକାଲ ସିଗ୍ନାଲ୍ସ ଆଣ୍ଡ ପାୱାର।
Electrical signals and power। ଆଉ କ'ଣ ଜାଣିଛ?
It used to amplify the signal.
As an amplifier it can be used। Right। तो first मते बेसिक स्ट्रक्चर को बेसिक जो कहला 3 टर्मिनल तो कौन 3 टर्मिनल माने कौन बुझुचो?
Ma'am, when a N-type semiconductor is sandwiched between two P-type semiconductor or a P-type semiconductor is sandwiched between two N-type semiconductor, it is become a transistor.
Correct।
ମ୍ୟାମ୍ ସେଥିରେ ବି 3ଟା କମ୍ପୋନେଣ୍ଟ ଅଛି, କଲେକ୍ଟର, ବେସ୍ ଆଣ୍ଡ ଇମିଟର।
Very good। ଲ୍ୟାବରେ ହେଇଗଲାଣି ନା ଏଟା ଆଗରୁ ପଢିଛ?
ପଢିଥିଲ ପ୍ଲସ୍ ଟୁ ରେ, ମନେ ଥିଲା ଟିକେ ଟିକେ।
ଆଚ୍ଛା, very good। So normally we will see what is our transistor। Okay। So there are the just the configuration are there। मैं first तुमको basics रो start करबे। Okay। Suppose let's take first transistor। As you have already someone has told that transistor consists of 3 terminals, right? It is a 3 terminal device, and you can say a transistor is consist of 2 p-n junctions। You can say a transistor is consist of 2 p-n junctions। Okay। Two p-n junction। Why 2 p-n junction? Because already someone has told that the NPN or PNP like that, two transistor you have already told you have already told me that NPN and PNP, right? So how it will create? You will see 2 p-n junction if we are connecting back to back, like suppose one p-n junction is there. Now I am connecting another one। Okay। Now this one is one junction, this one is another p-n junction, right? So this is one junction and this is another junction, right? Suppose 2 p-n junctions are connected to or you can say a transistor is consist of 2 p-n junction formed by sandwiching either 2 either p-type or n-type semiconductor in between a pair of the opposite type, or you can say the n-type is being sandwiched between 2 p-type, or you can say one p-type is sandwiched between 2 n-type material, then that is called as your transistor, right? So a transistor is a 3-layer device, right? 3-layer device. What are the 3 layers? This should be 3 layers. Among these 3 layers, 2 layers will be of same type. 2 layers will be either p type and 1 layer will be of n type, then that will be PNP. If it is 2 layers are of n type and 1 layer is of p type, then that will be NPN. Now what are the 3 regions? There will be 3 regions. What are the 3 regions involved?
emitter, base, collector।
Emitter, base, collector, right? You can say 3 layers are there, emitter, or 3 regions are there, emitter, base and collector. Hence, there are 3 terminals are also named according to these regions. One is emitter, one is base, one is collector. Okay, emitter, base, collector. Right. So there are 3 terminals taken from each type of semiconductor layer: emitter, base, and collector. Acha, according to the width, you can say co region ro width सबठो अधिका हेतिबो, co region ro width अधिका
Collector.
हेतिबो.
Collector.
According to width, collector has the largest width in comparison to emitter, then it will be base. According to width, this is the sequence. Okay. So collector has the highest width, then the emitter, then base. Okay. According to doping, emitter has the highest doping concentration, then the collector, then the base. This is according to doping. Okay. The emitter is heavily doped so that it can inject large number of charge carriers, electrons or holes into the base. Okay. Emitter kamo kona emit karibo, right? So it will inject large number of charge carriers. Charge carriers means electron and holes. What will be the majority charge carrier? In N type, electron, and in P type, holes, right? So it will inject large number of charge carriers into the base region. Now the base is lightly doped. The base is lightly doped, right? It is the highly doped one, and it is lightly doped. Why it is being lightly doped? Why it is being lightly doped? This is the base region. Why it is lightly doped?
I think so emitter गुडा सब जो either electron को transfer करे भाई जो depletion एटा कमी गले सुविधा हो.
Right. The base is lightly doped and very thin because it passes most of the emitter injected charge carriers to the collector. The emitter ru kon hobo charge carriers inject hela to the base, ana nahi? Charge carriers will be injected. Now base is very lightly doped, so e kon karibo sabu tako ko pass kari dabo towards the collector side. Right, it is lightly doped as well as it is, you can say here, in the width also it is the very minimum, it has the very minimum value, means base has very thin layer, and width bhi kam achi and doping bhi kam achi, right? So it is very lightly doped as well as very thin layer, so it will pass whatever the injected charge carriers are coming from the emitter side, it will pass them towards the collector. Collector ra kam kon collect karibo, right? So the collector is always moderately doped. The collector is always moderately doped. Moderately doped because it will collect all the injected charge carriers from the emitter which passes through the base, it will collect them, right? So that's why its name is collector and it is moderately doped. And it has highest width. Okay. बुझी पाला ना बुझी पाला नहीं?
Yes, ma'am.
Already जानी चो मुझे खाली revise करूँ. Right. So बस मत कह दियो emitter रो काम कौन? Emitter रो काम कौन?
To emit or inject electron.
Yes, it injects charge carriers. Electron nahi, it injects charge carriers. Okay, it injects charge carriers. Now, always remember the emitter is forward bias with respect to base. It will remain in forward bias with respect to base. Or you can say your PN junction, this one should remain in forward biasing state. Why? Because it will move forward the charge carriers, right? So in PNP, it supplies, if you consider PNP, it supplies the holes to the emitter base junction. When coming to the NPN, it will supply electron because N has in the N type material the majority charge carriers are electrons? Yes or no? In case of p type,
Yes.
the majority charge carriers are holes, so it will provide holes or inject holes towards this junction, or in case of NPN, it will inject these electrons, right? So this junction is called as emitter base junction. Okay. This will look like this. Okay. So this junction is emitter base junction. Okay, I'm repeating. This type, this is the base, this is emitter, and this is collector, right? So you can say this is the junction number 1, and this is PN junction number 2, right? So what is junction number 1? That is emitter base. Junction number 2 is collector base junction. Correct or not?
Yes, ma'am.
So this emitter base junction should remain in forward biasing mode. Okay. And this collector base junction always remains in reverse biasing condition. Okay. So now for the base one, the middle section is your base section, right? And it is very thin layer, right? Now the base emitter junction is forward biasing junction. So base emitter junction is in forward biasing mode, right? So allowing the low resistance, it will provide forward biasing role kon habo eti kichi depletion layer ta kam rahibo mane nai. So low resistance path provide karibo for the charge carriers to flow from the emitter to the high resistance, yes or no?
More.
More provide high resistance. Why high resistance is required? Because the charge is coming from the emitter, it will pass base to the collector side, but collector नाम कौन से collect करियो से आखिर ना वापस emit करियो जदि से वापस को रिटर्न दबो ताले तो प्रॉब्लम होबो माने नहीं so यार काम खाली collect करबो that's why we are providing here reverse biasing condition so the resistance path will be more, right?
Yes, ma'am.
Now we will see this type of transistors are called as BJT. What is the full form of BJT? What is the full form of BJT? This type of transistors are called as BJT. What is the full form of BJT? Don't know.
No, ma'am.
Bipolar junction transistor.
Oh, ma'am.
Bipolar junction transistor. Achha, why this name bipolar junction transistor? Bipolar means
दुईटा सेम पोल अछि पीपी आइदर एन एंड पी
Bipolar means both type of charge carriers, means holes and electrons participate in the injection process, okay, into the oppositely polarized material. That's why the name is bipolar. Okay, so both takes part in conduction method. Both electrons and holes takes part in the conduction. That's why the name is bipolar. Now, why this junction? You know, there are two junction: emitter base junction, base collector junction is there. That's why this junction term is here. Why this transistor? Why this name transistor?
Because it is transistor.
Transistor is nothing but, you can say, trans plus istor. Yes or no?
Yes.
Yes, ma'am.
So this trans so this much is one coming from one term and this much is coming from another term. Trans is coming from the word transfer and ester is coming from the word very familiar to you, that is register, right? Yes or no? Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right. So why this is transfer of register? That's why this word is transistor. Why this transfer of register? Why these two terms are involved? Transfer and register. Why these two terms are involved?
Ma'am,
Transistor.
because it
Ma'am,
transforms a single signal from low resistance path to high resistance path.
Or you can say right from the input resistance to the very high input resistance to very low output resistance, because it as you have already known that it acts as one amplifier. Amplifier काम कौन? Amplifier काम कौन?
ma'am, signal
Suppose this is my
amplify
input
करवाना है.
signal, then output will be one amplified version. Yes or no? Amplitude will
Yes,
be
ma'am.
high. So how is this possible? Because this must have some high resistance and this must have some low resistance. Low resistance हेले कौन होगा?
Amplitude बढ़ेगा.
Amplitude will increase.
Amplitude will increase. That's why you can say transfer of resistor, because it you can say it is the combination of transfer and resistor, because it transfers the resistance from one end of the device to the other end. Okay, very high input resistance and low output resistance. That's why it works as an amplifier. Okay, are you getting my point or not? ବୁଝିପାରିଲ ବିଜେଟି ମାନେ କଣ, ଟ୍ରାଞ୍ଜିଷ୍ଟର ମାନେ କଣ? ବୁଝିପାରିଲ ତ?
Yes, ma'am.
So there are, so what are the symbols? You know the symbols? Symbols ଜାଣିଛ କେମିତି ଥାଏ NPN PNP ର? How the symbols of NPN PNP look like? This is P, N, P. Very thin layer is my base terminal. This is emitter and this is collector. Emitter, base, collector. Same goes with this one. Right. So again, N, P, N. This will be emitter. This terminal is base and this terminal is collector. ठीक अच्छे? ठीक अच्छे तो?
Yes, ma'am.
So how will the symbol केमते देखा जिवो? See, is it visible to you? Is it visible to you?
Yes, ma'am.
So BJT is a three-terminal device, so you can encircle one transistor like this. Okay, this will be the structure, and the upper one is suppose emitter, base, and collector. Okay, so emitter to base. If the current flow direction is from emitter to the base, okay, emitter to the base. Okay, you can see the direction here given from the emitter to the base. Then this is PNP transistor. Okay, if the direction is from the base to the emitter, from the base to the emitter means outward direction, then that will be your NPN transistor. Clear? Clear or not?
Please repeat.
Yes, ma'am.
Okay, in some books this upper one is emitter, base and collector. Okay, and तमे एमती भी करि परिबो simple. And again to okay, you can use like this also. So this will be your collector terminal, this will be emitter terminal, this will be base terminal. For PNP, co-direction roibo. Emitter to base, right? Right
Yes,
or
ma'am.
not? Emitter to base, and for NPN, it will look like this. Okay, collector, base, emitter, and it is in outward direction. Okay. Now there are some configuration involved. Okay, there are three different type of configuration. Okay, so one is common. Mute करो. Common, base. Okay. Next one is common, emitter, and next one is common collector. Okay, according to your terminals, three type of configurations are there for your BJT: common base configuration, common emitter configuration, and common collector configuration. Okay, what do you mean by these three configuration? कौन बुझुछ? ये सब जिनसे सुनी चाह करो, right?
Yes, ma'am.
Yes, ma'am.
So what is common base, common emitter, and common collector configuration? See, common base means base terminal should be common to both input side and output side. Okay. Base terminal should be common to both input side as well as output side. Common emitter means emitter terminal should be common to both input and output, and that should be connected to the ground as well. Okay, same thing with common collector. Collector terminal should be common to both input side and output side, and that should be connected to the ground as well. Clear? बुझिपाला ना बुझिपालानी? बुझिपालो तो? This connection the main aim hoji, you will connect this base terminal to both input and output, that is common base. Common emitter means emitter should be connected to both input and output. Collector is connected to both input and output side. Okay. So what are the configuration and how will you derive these things? We will study. First, start with transistor operation. Okay. So can the transistor okay, I guess for the next modeling part or the operation of the transistor, we will study in the next class. Okay, up to these three configuration, it will come, and how this transistor operation is occurring, operation and configuration, we will study in the next class. Okay, let me take the attendance
Yes, ma'am.
first.